go back to so this is also in the frameworks. The standards are really not intended to just be new names for old ways of doing business. They're really called to take that next step. It's time to recognize that the standards are just promises we keep to our children, or promises we intend to keep. And standards by themselves cannot raise achievement. We realize that. Standards don't stay up late at night working on lesson plans or stay after school making sure every student learns. It's you, the teachers, that do that. And standards don't implement themselves. The leaders from the state board to the building principals make sure that the standards are a reality in the schools.
And this was written by the authors of the Common Core. So I think it was really important to acknowledge that that's great we have standards, but it's teachers that bring them to life. And it's your hard work, staying up late, consulting with colleagues about a student that's struggling, designing lesson plans to meet the needs of the kids in your class. That's what's going to make a difference. So we just want to make sure that we acknowledge that.
There are 5 essential understandings and big ideas in our Common Core that impact how you teach and how your students are going to learn. And Mary had gotten this from her experience about the 5 pillars for mathematics. And these do incorporate the standards for mathematical practice as well. You know, we really want our children to know that they're going to be competent mathematicians, and they're going to use math, as I said, every day. And they really, it's going to be exciting because math makes sense and it's logical. So we want students to expect that math will make sense and that they draw upon what they know to solve problems. And we feel that productive use of discourse will help them to explain and justify their math thinking. So students are going to, as I said before, make conjectures, be able to defend their ideas, listen, and make sense of the reasoning of others. I think this afternoon we'll definitely address the third point for sure. It's that procedural fluency. When you instruct math, you do want to balance between the fluency of working with computation and the conceptual understandings for your grade level. So we want students to be flexible thinkers, accurate, and use efficient strategies. Develop a sense of what strategies look like and then help them to decide which is the most efficient. We want them to be flexible in appropriate use of mathematical representations. We want them to understand math vocabulary. We want them to use it as they express themselves. We want them to be able to model equations and show us their diagrams and work through problems. And we want them, the more that they do this and the more that they share with us their efforts, they're going to become confident and they will persist. And they'll be intrigued about the problem that you posed in the morning that doesn't get solved until the end of the next day. And hopefully they come with you with consistent kinds of efforts along the way. Anything else there, Mary?
Just to reinforce that this is what we encourage you to have in the back of your minds all of the time. Those 8 practices and the 5 basic pillars to be thinking about.
So I pulled this from one of the books that you'll receive, Using Math Talk to Help Students Learn. And I liked it because I think talk not only exposes their accurate thinking, but it's also going to expose their misunderstandings and their flawed logic. And it can be used as a way of a formative assessment. If several students share with you something that's just slightly off and it's going to lead them down the path, and other students are agreeing with that student, that's okay. Because then you already have a collective small group that you want to address, and at that moment, sort of help them to understand that that might not just work the right way. And let's sort of continue, let's sort of change that up a little bit. So asking students to talk about mathematical concepts, procedures, and problem solving helps them understand more deeply and with greater clarity. But getting students to talk about mathematical ideas and procedures can bring to the surface the gaps in their understanding.
And I think when you saw the title of the workshop being Math Discourse, I remember hearing that term for the first time this summer. And discourse isn't something we usually encourage in our classrooms. We want everyone to get along and not be disagreeing with one another. However, when people do sometimes disagree, as long as it's done respectfully, it can help you come to a deeper understanding of the issue at hand as you listen to other people's ideas and try to justify why you think the way you think, and come to the answer to the problem. So I think you'll get a chance to experience some of that today, and we'll begin.
An author that I love that you probably are well aware of is Marilyn Burns. She has a published company, Math Solutions, where the Using Math Talk book is from. And she is a prolific author, journal articles as well as books. But the idea of our standards are really, they're essential, they're research-based. They are sort of aligned with sort of a backwards design model. So they started most likely in grade 12, thinking about what do students need to have in place for college and career readiness, and backwardly designed what each preceding level needed to have. So they're very coherent, they're very rigorous, they're internationally benchmarked, and so I think if we truly teach to those standards, we'll have a job well done. But Marilyn Burns talks a lot about, when we present a concept, all the underlying, preceding kind of competencies that need to be in place to the understanding of that concept. So she describes it, compares it to the layers of an onion and peeling an onion. So consider, if you will, the computational task of learning to multiply 683 times 4. To be successful with that computation, the student really needs a set of skills underlying to be successful with that task. Think for a moment to yourself, what are those necessary conceptual layers to successfully solve 683 times 4? And then if you would, talk with your table mates or your elbow buddies, and what collectively do you think are the layers for a successful computational answer?
You're on, Steve?
Testing.
me to do anything?
When they give both answers, Steve's going to try to go around with the board for Mike to
Class, 3 times, if you can hear me. All right. Any table or individual want to share? What did you think were the competencies that a student would need to know in order to solve 683 times 4 successfully? And Steve has a mic if you would like to be amplified.
Oh.
Yes. So they have to know their basic facts, correct? Yes. They have to know the recognized numbers.
They have to know that 8 is not just 8 times 4, that it's 80 times 4, and that 6 is 600 times 4.
A knowledge of place value. It's not complex.
At the very least, they need to know that 683 is a group, and then you have it again and again and again. And it's simple, 4 times 3, but they need to have that understanding of addition because that's 3, 3, 3, 3, or 4, 4, 4. So there's a lot of, they even need to know greater than and less than because when they get their final answer, they have to know that it's going to be bigger than 683. So there's all these little basic things they need to know with kindergarten, first grade teachers.
Place value, facts, multiplication, addition, estimating, distributive property. They're going to do it that way. Knowing it's going to be an even number, right? Rima, what does the symbol mean?
Check their answer.
You multiply right to left.
Multiplying right directionality. I'm sorry, check their answer. Good? Good. So many, many layers, and oftentimes you'll see students in your class come in different entry points and get be very proficient at this or to be stuck at certain levels. I just want to share with you, and you don't have to write these down, but Marilyn Burns, she suggests 9 strategies that we incorporate in our math instruction, and to be thinking about those layers, and that you will have students in your group of 20 that are very diverse and come to you with diverse abilities. So think about how you can scaffold the essential mathematics ideas that you are instructing. Pace your lessons. Kind of read your crowd. Like I'm reading you. We're going to get up shortly. Pacing the lessons and understanding that they can only sort of hold on to so much verbal information before they got to act on it and do something with it. I love this one. You know that students are going to need additional time and support. Build that in. Don't expect that every single 22 students sitting in front of you got it the first time. So just understand that for some it's going to take a little more time. Make that part of your plans. Foster that student interaction. So as much as we love to hear you instruct, I'm going to be going around and looking for academic productive talk from my students. We'll have to build those connections between new concepts to previously learned concepts. They'll begin to do that, but we'll have to make those connections explicit. New learning is connected to old learning, and this is how it's associated so they can make those building blocks. Encourage mental calculations. You'll hear more about that, but that places a reliance on the students' understanding about number, understanding about place value, the ability to hold on to numbers, manipulate them. You'll hear more about that, but I think that's a key piece. And I love this visual. She helps students to use written calculations to lead